Welcome to my channel. The last video we have covered binary trees implementation using linked list, and this video will be covering implementing the binary trees using array. Okay, so before starting the code, let me explain one important thing regarding trees. So here, when we have trees, okay, we know like what is a binary tree, which has only one children at least minimum and at most two children, then that is called a binary tree. So think that this is a binary tree. So now we just convert this to an array. Okay, so here I'll be having some value. Just let us have it as 10, and this is 20, and this is 30. Okay, so what happens if you write this tree in an array? Okay, what happens if you write this in, okay, let me write this, you're fine. So what happens if you're writing this in an array? So consider this is an array. Okay, so if your array starting with 0, okay, the index starting with 0, then what happens if left child will be stored in the position 2i 2i plus 1. Okay, so left child will be stored in the position 2i plus 1, and right child will be stored in the position 2i plus 2. 2 into I. So I will be your root. Okay, 2i plus 2. So this is for your MCQ questions. Okay, you can just attend the MCQ questions when you asked with converting a tree into array. Okay, and see that your index is starting with 0 or 1. If it is starting with the index 0, then you can just follow this. Okay, your left child will be 2i plus 1, and your right child will be stored in the position 2i plus 2. Okay, and if your index is starting with 1, okay, in this position what happens now, your left child will be stored in 2i. Okay, only 2 into I, that's it, 2 into I. And your right child will be stored in 2i plus 1. Okay, 2 into I plus 1, that's it. Okay, you have to remember this logic to write your tree in terms of array. Okay, so always your root will be in the first position, either in the index 0 or index 1. Okay, so this you have to remember. When your index is starting with 0, then your left child will be in the position 2 into I plus 1, and right child will be in the position 2 into I plus 2. And when your index is starting with 1, then your left child will be storing in 2 into I, and right child will be storing in 2i plus 1. Okay, okay, fine. Now let's start with implementation of your program, okay, using array. Okay, first let's include your header file. So we'll just include the header file stdio.h, and then so as you speak with array, the first and foremost you have to predefine your capacity of the array, right? So now let us define the capacity or size of your tree. Okay, let me just go with defining through macro. I just give size, I'll just give 15. Okay, 15 or 5, anything fine. You should not give semicolon over here. Okay, next is like I'll just go with the main function. Okay, I'll just go start with the main. Okay, this main function, what we have to do, we have to first declare your tree. Okay, I'll just declare the tree. So with the size, okay, with the size, predefined size, so your size value is 15, so I have been declared an array of size 15. Okay, a tree of size 15 has been declared. Okay, what happens now, Now your array of size 15 has been declared. Let me draw this. Okay, let me draw this. So we have a tree. For your simple understanding, I'll just have the size as 5. Okay, the size of 5. So here we'll be having 0, 1, 2. Okay, this will be the 0th index. This will be the 1 index, 2, 3 and 4. Okay, index will be always n minus 1. So I have been created a tree of size 5. Okay, size I have given 5 now. Okay, now I have declared the array. Next what we have to do? We have to initialize all the elements. Okay, if your elements are there, okay, I need to have empty tree first initially. Okay, I'll just have that in a loop. I'll just have one more variable I for loop. Okay, I'll just have for I is equal to 0, I less than size, and then I plus plus. So this is to just bring all values to minus 1, so that my tree will be in the starting will be empty tree. Okay, I just initialize all the elements in the tree to minus 1. So we always know that when you have the array, to declare or to initialize the, so we know that when we have array, minus 1 indicates empty, either tree or a stack, anything. Okay, so now I have just initialized all the elements of the tree to minus 1 to indicate that my tree is an empty tree. Now I'm just going to manually insert, okay, the elements. Okay, so here I just have a method called insert. I'll just write the definition of that. I'll just pass the entire array of tree, because I need to load all the elements into the array, right? So I need to pass the entire array, and then I have to pass the index position where I want to insert and what value I have to insert. This is my array, and this is my index position and what index I have to load it, and this is the value what I want to insert in that array. Okay, so same thing you can just copy. So this is a root actually. Okay, starting index will be a root node, and then this can be copied and this can be replicated. uh, okay, I'll just write it here. So this is your left child. Okay, so we know that when you're starting with 0, we know what is the value, what is a position of your left child. It should be 2 into I plus 1. So my I is 0 here because I is root. 2 into 0 is 0 plus 1, which is nothing but 1. So it is loading in the position 1. Okay, so that is my left child. Okay, and then what is your right child position? It will be 2i plus 2. 2i plus 2, again your I is 0 here. So 2 into I is nothing but 2 into 0, it is 0, and plus 2, it is nothing but the second position. Okay, so my right child will be storing in second position. So I'll just give 2 here, and I'll change the values to 20 and this to 30. Okay, and this is my right child node. Fine. And so let me comment it. Fine. Okay, next again what I can do is, so again you can just have that left child of that. Okay, I'm just extending whatever it is in the left subtree and the right subtree. Okay, now I'm just having that, I'm going to extend the left subtree, right? So what is the root of that? Root value is now 1. Now I value changed to 1. So where which what I have to do? 2 into I, which means 2 into 1 plus 1, which means 3. So index position 3, we have to save or insert the left child of the left child of the root. Okay, so I am going to extend my left subtree. Okay, so this is 3 now. So left child of the node at index 1. Okay, because that is the root for that. So for a better understand, I'll show you how it is working. So what we can do is, so here I have my root and this is my left child. It is in the position 1 and this is my right child and this is my position 2. Okay, so now I'm inserting a left child for this. So in this case my root of this child is this. Okay, so my I value is 1. So what happens? So 2 into I is nothing but root. Now the root is 1 actually. So 2 into 1 plus 1, because my index value is 0 here, to 2I plus 1, which is nothing but 3. So at index position 3 I will be storing this left child of the node which is at index 1. Okay, so this is your position 3. Okay, that's what I did here. Fine. So next what I have, 1 2 3 4. So totally the size is 5. So I can insert one more element. I can just insert the right element. So right element is same way. So what I have to do, right child. So for this I am going to insert right child. So right child value will be 2I plus 2. 2I is nothing but at the index node 1 I am going to insert the right child. So my right child position will be 2I. I is 1, 2I plus 2. Always we know that for left child 2I plus 1 and for right child 2I plus 2, which means that 2 into 2, 2 into 1, 2 plus 2, which means 4. My index position 4 is given for the right child of the left child node which is at the index 1. Okay, so here I'll just give 4 here. Okay, and this is 50. I'll just give it like that, so that I can say that this is the right child of a node at index 1. So now I have been created a tree, inserted values 10, 20, 30, 40 and 50. Okay, so here what happens, I have inserted 5 values here. Okay, so now you can understood what I have done. I have just created a tree like this. Okay, now let's write a method now. Okay, we have just completed the main function. Main function, what we did, we just declared the size of the tree and then we have just initialized all the elements in the tree to -1 to make that tree is empty tree, and then we have just called the method called insert. So we have called but we didn't define it, right? So we are going to define that now. Okay, so let us define that. Okay, I'll just let us define that method insert. Okay, void insert. This method takes up what? Takes up the entire array and then it takes up the index position and takes the value. Okay, let us pass these three parameters. So int tree array, and then I'll be passing an index also. So index comma, and I'm passing the value also, int value. Okay, so these three parameters it is getting passed in the method call. Okay, what I'm just telling now, if. Okay, because we know that when you are inserting an element, it reaches the n minus 1, which is nothing but index 4, because my size is 5, right? So if that index position is reaching above the size, then I have to say that out of the bound, or it is the the size is getting overflow. Okay, in that condition we have tried if index is greater than equal to size, then what I have to do, I have to just give a message stating that printf, it just index is out of bound. Okay, anything you can write, no issue, index out of boundary. But in stack we mentioned that is stack overflow and underflow, all these things, but in tree we cannot say that it is overflow, we can just say that it is out of boundary. Okay, so this is a message I'll be getting when my index is greater than equal to n, that is your size. Fine. Okay, so this is completed for checking the conditions. Later on what I have to do, if again one more thing, if my tree index is not equal to minus 1. So, because when your tree index is equal to minus 1, right, which means it is empty, so that I can insert some elements into the tree, right. If that is not equal to minus 1, then I can say that printf the position is already occupied by some elements. Else what I can do, I can insert the value. I can insert it? I can just give tree index on the that particular index position. I'll be giving the value whatever I want to insert. Okay, that's it. So this is how you insert the values. What we did, we just defined the method by passing three parameters. One is the array, another is the index, another is the value. Okay, and once you just come in the starting of your definition, we are checking whether your index value is equal to size or greater than equal to size. If that is a condition true, then we have to print that your index has been reached the boundary. Okay, and if your index position is not equal to minus 1, which means that it has been already taken up some value, so in that case I can say that position is already occupied. If these two condition is false, then I can simply give that value and I can simply assign the value to the particular index of the array. Okay, what index we have passed, in that index we are giving that value. Okay, this value is given to this index in this array. That's it. Okay, this is your definition of your insert method. Okay, so we have inserted. Now the important thing, to traverse the tree. After inserting, what we can do, we have to display, right? So in that case we can just again you can just give a definition of that. Void display or traverse, anything you can write. Void display, again we are passing an complete array, because I need to just get that all the elements in the array, right? So and also I have to get the size also. Okay, so size, so here, so I'm just looping into. Okay, so in this case what I have to do, so I can just get some printf value, so where the printing the binary, anything you can write it. Okay, anything whatever you write, you can just have that message, you can just display on the output screen. So printing the entire binary tree in array form, we can just write like that, because we are implementing in array, right? Okay, so in this case I'm just looping it, because I have to loop for the entire array to get the element and just print on the output screen. So for int I equal to 0, so because my index is starting with 0, then I less than equal to, not equal to, it is less than size. Okay, less than size, that's why we have passed the size over here. Then I have to increment now each time, like I have to go from 0 to this size, 0 plus 1, again 1 plus 1, something like that. So in that case I'm just giving increment of your I. So once I'm just looping it, what I have to do, I have to just check whether if your tree is equal to not equal to minus 1 or not. Okay, so in this case, if tree array I is not equal to minus 1, then only I will be going to fetch all the elements, because if it is equal to minus 1, which means the tree is empty. If it is not equal to minus 1, then I can do what? Again I can just have this one more check conditions. After that I can just print all the values. Okay, so the elements in the tree are B tree. Okay, we can just give like that, B tree. Okay, you can just give percentage the format specifier and followed by comma. So in this we'll be giving so tree array I. That's it. So what happens now, once for the display, I'm just looping the tree, entire tree. In this case I'm just checking with the condition, if my tree is not equal to minus 1, then only I can say that the positions are occupied, so elements are there in the tree, so that I can just get all the elements. If your tree of I, which means I is nothing but index, okay, if the tree of that position is equal to minus 1, then your tree is empty. So I could not get the elements from the empty tree. Okay, that is the important thing, you have to note it. Okay, so this is thing completed. Okay, I just call this method display method in the main function, so that you can just get that tree. Once after inserting, you can just get that display of, I have to pass the array and then I have to pass the size. So size, I'll just pass this. Okay, so we have completed the program, and we'll just see execution part. So what we did, we just defined that size, and we have given the size also over to the display method. So we just check it whether any mistakes we did. So we have just declared the size. Okay, everything fine. We'll just execute for the program output. Okay, you can see here. So now we got that output. So I got some errors. So the error is like I have missed out the function prototype. So here this is your function prototype. So please make sure that you are including this on top of the main function. So whatever the method you are going to use in the program, that you have to declare here. Okay. So and what are the parameters you are going to pass for that method. Okay. Only for this I got the error, and now it is working fine. So in this case, you can just give some new line so that you get better look for your output. Okay, so here what I'm going to do, I'm just going to print the elements. Okay, so in this case, you can just give new line, and you can just try executing again. Okay, and also here also one new line, let's give it. Okay, so this is for your better look into the output, so that you will get some idea. Yeah, see, so better, right? Before it was very crispy and clumsy, and now it is very neat. Okay, now you can see like the elements in the tree. Okay, the displaying of that, because I've called the display functions in the main function. So now it is working. So this particular method, it is throwing us the element after inserting it. So we have inserted 0, zeroth index, we have inserted a value 10. So now it is there, 10 is there in the zeroth index. You can just, if you want to get that index also in this output, you can just pass the I value here. Okay, here 1 minute, let me, the element in zeroth in, I just pass that index here in zeroth index. Okay, zeroth position, I'll just write that zeroth position of the binary. I'll just write like that. So this percentage d will have to replace by your index, by your I. I'll just give like that, so that you'll get better idea for each and every index. See how it is very neat. The elements in zeroth position of the binary tree is 10, because we have inserted that 10 in the zeroth position. Okay, and again we have inserted 20 in the first position. So each position I have mentioned, so that you'll get clear idea the values and the position. Okay, so that's it. Okay, I'll just summarize what we did. So regarding the implementation of binary tree using array, so array means it's a static memory. We have to predefine the capacity of the size of your tree. So that's why I've used macro. So macro hash define, I have given size as 5. You should not end up with a semicolon. Okay, and then you have to give the function prototype. So I'm going to use two methods. One is for inserting an elements into the tree. The other is to traverse the tree and just print all the elements into the tree. For this insert method, we are passing three parameters. One is the array, the other is index, and other is the value which I want to insert it. This display method will be having the array and will be having the size. So in the main function, what we did, we just declared the array over here, the tree array, and we are just initializing all the elements to -1. Only then we'll just have that empty tree, and manually we are just inserting the value. For this insert method, we are passing the array, and we are passing the index position, and we are passing the value to be inserted in that index. So always your starting node will be the root node, and for the left child, if your index is 0, the left child position will be 2i plus 1, and for the right child, the value will be, position will be 2i plus 2 if your index is starting with 0. Okay, so this method defined here actually. So for that particular method, we will be like defining when your index position is greater than equal to size, then we have to print that your index has been out of the boundary, and if it is not equal to -1, then I can say that the position is already occupied. Okay, if the particular index, okay, like if I'm just giving a 0 here, and the 0 should be minus 1, only then I can insert that value into the index. If that is not equal to minus 1, because initially we have just initialized everything to minus 1. So minus 1 is nothing but empty, so which takes up the value. If it is not equal to minus 1, it is already occupied, so the value cannot be inserted into the particular index. That's the logic here. So you can just try here, okay, the same thing you can try. So you can instead of having this 4, I'll just insert the 0th index. I'm just passing here, okay. So here it is like, and the 0th in the index already element is inserted. You can just try here and you can just see the 0th index position again for this will not be executed, okay. 0th position we already 10 is inserted, this is not inserting it, okay. Okay, so we got the message stating that the portion is already occupied, okay. That's the case. So that is why we just given this tree index is not equal to minus 1. Not equal to minus 1 means like this 0 is already occupied by 10, okay. By the 4 is already is given as minus 1, okay, because we initialize that is minus 1. So if we are passing the index 4 here, then I can just get that value. Okay, so if I'm just executing it, because the index position 4 is minus 1, so now the 4 is minus 1, it is not equal to minus 1, so that's why we are just having that it is equal to minus 1, that's why we can able to insert the value on that particular position. So that's a logic here. And for display we just given a loop for the tree. For each iteration we'll get that I value, and the I is slowly incrementing until your size is reached. Okay, if the tree is not equal to minus 1, then only the elements will be there in the tree. If it is equal to minus 1, then it is an empty tree. Okay, so we have to check this condition. If the tree is not equal to minus 1, then we are just getting that elements from the each index portion of the tree. Okay, so that's it regarding your implementation of binary tree using array. If you have any doubts, please ping me in comments. Thank you. Happy learning.